Hi, I'm Ian Griffiths, and this is a talk from the Building Business Applications in Silverlight series. In this talk, we're going to take a look at webcams. So in our example application, one of the features we want to support is the ability for end users to provide a picture of themselves. And there's a couple of reasons we might use that in our application. It might be that when the users actually turn up at the events being planned, we'd like to just compare their face against the image we've got stored to make sure no one's turning up and pretending to be someone they shouldn't. And also, maybe we'd like to add some sort of online forum feature and let people use their images as avatars if they want to. So we're going to use the webcam feature of Silverlight 4 to let them capture an image of their face and upload it to our application. So, the API for working with the webcam consists of three important classes, or four if you're doing audio. So the first one is the video capture device, and this represents a particular camera attached to your computer. And if you're doing audio, there's likewise an audio capture device to represent the microphones attached to your computer. Then we have the capture device configuration class. This is the thing that we use to discover which devices are available. So how do I get hold of a video capture device? Well, I ask the capture device configuration class to give me a list of all the cameras attached to my system, or I can ask it for the default camera. Of course, some systems don't have cameras, so your code needs to be ready for the possibility that it gets nothing back from the list and null back as the default camera. But as long as the camera is attached, we can find out which the default one is. We also use this class to request permission from the user to access the device, as we'll see in a moment. The third class, capture source, has a slightly less obvious purpose. The capture source's job is to represent, in an abstract way, a thing that video and sound can come out of that can then be connected into entities that are able to do something with that media. So for example, the video brush is able to accept a capture source. So we can tell it we'd like it to paint with video coming out of some sort of source object. There's also a class called a video sync, which you can derive from, and you can write code that is delivered all of the frame information coming out of the camera. So you would derive a class from that and override a method, and every time a new frame is captured, you're given all the pixel values in a big array. The capture source is there because simply identifying the camera is a relatively cheap operation, whereas turning it on and starting to acquire imagery is a rather more complex one that requires the system to dedicate more resources. So for example, on Windows, it will probably involve something like setting up a direct show graph or the equivalent in Media Foundation. And on the Apple Mac, something similar is going on. Also, you need to turn the camera on as well, and the capture source provides the control mechanisms for that, and the capture source provides a place to unify audio and video into a sort of a single thing, because you want those to be synchronized if you start doing further processing of that. If you've got two independent devices, something needs to unify them into a sort of a single media stream so you can keep lip sync. You want to make sure that you don't get the person's moving lips getting out of sync with the sound that you're hearing. So the capture source really is there as a very simple abstraction on top of those complex ideas. It represents a thing that media comes out of that you can then plug in to something that knows how to process media, such as a video brush. So here's an example of how we can discover what devices are available. So I'm calling the capture device configuration classes getAvailableVideo capture devices. And in this case, I'm just putting that straight into a list box. The list box will then just use normal data binding to display one item for each object we put in there. And calling toString will be the default behavior. That's not terribly useful. If you call toString on a video capture device, it doesn't return any useful information. So instead, we bind to the friendly name property. The friendly name is typically the branded name of the camera, so whatever name it had printed on the box when you bought it, in all likelihood. So that's a good way of displaying the cameras available to the user. They'll know which one's which. If you don't want to let the user select, you can just instead pick the default one, and the bottom snippet shows you how to do that. Once we've got a particular device for capturing, we then need to wire it up. We need to basically set up the topography. We need to tell the system how we'd like video to be routed from the camera onto whatever we're doing with it next. And in this example here, we're going to connect it to the screen. We're going to use the video from the device to connect to a video brush that we're going to use to paint an element on the screen so we can get a live preview of the imagery coming out of the camera. So we start by creating a capture source, which we associate with the video capture device. And if we were doing both sound and video, we'd also plug in the audio capture device at the same point. Then we wire that into a video brush we call the setSource method. Video brush's setSource will either take a media element, so if it's something that's playing a media file, or you can connect it to a capture source, which is able to feed live video into it. And here we're just using that to set the fill property of some element on our screen. because the video brush can paint anything whose type is brush. So here we're using it to paint some shape on the screen. Now at this stage, all we've done is we've decided how we'd like the imagery to be routed from the camera onto the screen. Nothing is actually happening yet. We actually have to tell the capture source to go to start acquiring images before it will actually connect everything together properly. But before we're allowed to do that, we need to ensure that we've got permission from the end user. Silverlight says that, well, the camera and the microphone, if you could just start using those without telling the user you're doing this, that could constitute an invasion of privacy. You could put a tiny little Silverlight application on a web page and just start listening to what the user's saying without them knowing what's going on. So consent is required. And so we have to request device access. We only have to ask once for the duration of the application, and we can ask Silverlight if we've already got permission by testing the allowed device access property. And if that returns true, we've already got permission and don't need to ask again. But if it returns false, we don't currently have permission and need to ask the user, and they'll be shown a dialog. And if they say yes, then we can go ahead and call start. Finally, at some point, you need to stop acquiring video, particularly if you've got a navigation application that has multiple pages in it. Navigating away from a page that happens to be using the capture source does not shut down the capture source. It will carry on acquiring images until you tell it to stop, and the user's camera will have the light lit up until you do that and won't be available for other users. So it's important to shut the thing down, partly just so you don't unnerve the user, partly so you're not wasting resources, and partly so you're not stopping other applications on the computer from using the camera. Exactly when you do that will depend on your application. In a navigation application, you do it at the point at which you navigated away from the page. In other applications, you might do it in response to some other trigger, but you have to do it at some point, otherwise you'll keep the camera running. The consent dialog will look something like this. The user will be asked, are you okay with this particular website trying to use the camera and the microphone? And if they say yes, then we're allowed to go ahead. Now, for our particular application, it's not enough just to paint moving video from a camera on the screen. We want to be able to acquire images from the camera. We want to grab images as they come in and ultimately upload them back to the server so that our server can have pictures of the people using our application. And for this, we use the capture source's capture image async method. So this conforms to the .NET event-based asynchronous pattern, which means we have to wire up an event handler to the capture image completed event and then call capture image async once we've got that event handler set up. And when the next frame is available from the camera, that event will be raised. And in the event args, we can get hold of the bitmap representing the picture that got captured through its result property. That will be of type writable bitmap, so we can go and look at the pixel values if we want. In this case, we're just putting it into a brush. Now, in our application, we want to ultimately upload the data. And this actually presents us with a small problem. The obvious thing to do would be to turn the image into something like a JPEG and upload that, because a JPEG is a reasonably good representation of a pictorial image. It's an efficient way of compressing that without losing too much image quality. But unfortunately, Silverlight has the ability to decode JPEGs, but not to encode them, because those are two quite different processes, and obviously getting the Silverlight plugin to be reasonably small and a fast download was a high priority. So they don't build in functionality into the framework to encode bitmaps, because that's a fairly specialized thing to want to do. So you end up having to use some sort of library to do this. So for example, there's the image tools library up on Codeplex that you can download that provides services for doing things like PNG and JPEG encoding. I'm not going to show that in this section, but that's what you would then go on to do. Or you could just upload the pixel values. If bandwidth is not too much of an issue, then you could just push all the pixel values up to some sort of web service and then use the full .NET framework on the server side to do the image encoding, because the full .NET framework does include JPEG encoding as well as decoding. So let's look at this in action. I'm not actually going to do this in the context of our example application because I want to focus just on the details specific to using the webcam. So let's create a project called Webcam Demo. Don't need a website to host this one, just the plain Silverlight application will do. And the first thing I need to do is present a list of webcams attached to the system. So let me drag on a list box. And in the code behind, I'm going to populate that list box with the set of known video devices. So listbox1.items item source equals capture device configuration dot get available video capture devices. Let's make that a little bit smaller so we've got space to see what's going on. So this will populate the list box with all the known video capture devices. And as you can see, the default two-string behavior is not very helpful. It's just printed out system.windows.media.video capture device. It's printed the name of the class because that's what happens when you call toString, which is why we want to add a item template to my list box so that we can control how the individual items end up looking. So let's quickly do that. Not that one. That one. This will be a data template, and we just need the one element in here, a text block whose text is bound to the friendly name property provided by the video capture device. So now I should see the name of the camera, integrated camera, indicating that this is the one that's built into the laptop I'm using right now rather than an external one. That's what this laptop vendor has chosen to name their built-in camera. So next, I'm going to add a selection change handler to the list box so that when the user chooses to select a camera, I can attempt to do something with it. So, video capture device is the list box selected item cast to a video capture device, and just make sure there was actually a selection, make sure it's not null, that the user hasn't unselected something. And if that's the case, well then what do we do? As you saw on the slides, we build ourselves a capture source to maintain the process of actually streaming video through the system. So build one of those and set its video capture device to be the device we just selected. Then I'm going to build a video brush. And I'm going to set its source to be my capture source. And now I need to attach that to some sort of UI elements. Let's go back to the XAML, and let me just drag on a border will do. So small preview image there. And just because I can, let's set the corner radius to be 15 to get nice rounded edges on the thing. And let's give this a name. Call it live image preview. And I'm going to set the live image preview's background property to be that video brush. So I've wired up the source to the UI element I wish to paint, but nothing's going to happen yet. I haven't actually told the capture source to begin. So first of all, I need to make sure I'm allowed to do this. So I'm going to ask the capture device configuration, am I currently allowed to access devices? And if I'm not, then I better ask the user if I can have access. And then, if either we were allowed access already or the user just granted us access, then and only then can we call cs.start. So if I run this, I get asked, do you want to allow camera and microphone access? And in this case, it's got a file URL because that's where my Zap happens to reside, but normally you'd see a website URL there. And if I click yes, after a couple of seconds, I can see myself peering into the laptop. So that all seems to be working. So I've got a live preview up and running, but the goal was to capture a still image. So let's add another space to the user interface to hold the result, and let's have a button to actually go get it. So let's add another border. And a button to take the picture. Let's call it snap, and I'll call this snap button. And we'll add a handler. So at this point I'm going to need access to the capture source to acquire the image. Let me actually move that into a field. So it's going to be accessible to all the methods in my code behind. And in here, I need to wire up a capture image completed handler. And this gives me, through the result property a writable bitmap that is the captured image from the camera. So let me build an image brush with which to paint and set its source to be that result. That should be ib.imageSource. And then use that to paint that border I just added, set its background color to be that brush. So I should now find, if I run this, oops, what I got wrong? I left out the equal sign. So start acquiring images once the camera's woken up. Would help if I actually called the start method to kick the thing off, wouldn't it? So I've hooked up the event. The other thing I've got to do is to remember to say, OK, now I've done that, please go ahead and asynchronously capture the image for me. And click the camera, and off it goes. One last thing that's worth being aware of, particularly if you're trying to write code to do this and want to make sure, if you're having problems, you want to make sure the camera is actually responding correctly, is if you go to the Silverlight configuration page, we've got this tab here called Webcam/mic, which will show you all the available cameras and all the available microphones. Now, right now, it's not showing anything because I've actually got an application running that's already using the camera. Let me shut that down. It's a good example of why you need to make sure you do release the camera when you're done with it. But if I run this again and don't click over here, I should see in this page, it will go and find the camera, and after a couple of seconds, there it is. And you can also see the level coming in on the microphone there. And if you've got multiple devices, they'll be listed under here. So that's kind of a useful, just a tool to see that everything's working correctly before you start looking to see whether it's your code that's causing things not to work as you would hope. So that's how we use the webcam. We discover which device we're going to use by interrogating the capture device configuration class. We ask for permission from the user to use their camera, again through the configuration class. And then we wire up the device into a capture source, and then we can plug the capture source into a video brush, or we can use it in conjunction with the async image capture event to grab a single frame and get that into a bitmap. And from there, we can do whatever we like with the bitmap.